I'm Jinping. The title of my presentation today is Near-Term Future Sea Level Projection Supported by Extrapolation of Tide Gauge Observations. And this work is in collaboration with Shibin, Zhonchurch, Mankin, and Xinyao. We know sea level rise is a major consequence of global warming, and it's important to understand and quantify how much sea level will rise in the future, especially on coastal scales, since there are considerable density of population. The IPCC reports provide future sea level change under different emission scenarios based on model of these different contributors to sea level change. Also, the historical sea level observation alone can be used to provide near-term sea level projection based on the estimate of linear trend and acceleration and extrapolating them into future. This is also referred to as the trajectory in previous studies. These observation-based projections are independent from climate models, so they provide a useful and complementary validation for the AR6 sea level projection. This figure shows the global mean sea level projection by extrapolating the linear trend and acceleration from the satellite altimetry. We can see the sea level rise in 2050 is consistent with the IPCC's log projections within the uncertainty range. And there are also studies about regional sea level projection based on tide gauge or satellite altimetry observations along the US coastlines. So these observation-based projection methods has been used to inform future global mean sea level rise and also on a regional mean scale along the US coastline. And here we try to evaluate the sea level trend and acceleration for global network of tide gauge observations. And then they are extrapolated to provide local projections up to 2050 and then compared with AR6 projections. Also, we know that accessing the trend, especially the local acceleration based on local observation, can be challenging because there's a considerable natural variability in local sea level change from interannual to decadal timescales. So here we follow the previous study to use the tide gauge records from 1970 to 2023 with this longer tide gauge period to allowing for reduction in the impact of natural variability. Also, we use this multiple variable linear regression method to reduce the impact of those well-known natural variabilities, for example, PDO, ENSO, NAO, and etc. Then this linear trend and acceleration at individual tide gauge are extrapolated to 2050 to provide the observation-based projection, assuming the linear trend and acceleration stay unchanged over the extrapolation period. And here are some results. For the global mean sea level projection, here we compared the observation-based projection with AR6 and 3 emission scenarios. This arrow bar indicates the likely range, which means the 17th to 83rd percentile and the SSP 126, 245, and also SSP 585 scenarios. And we also compare with the low likelihood, high impact emission scenario, which means which defined as the 83rd percentile of the low confidence projection and the SSP 585 scenarios. This storyline represents the outcome that the probability of occurrence could be low, but like the S-rate instabilities, but its potential social impact could be very high. So here we compare with this low likelihood, high impact storyline from AR6 to inform the potential early risk warming strategies. We could see the global mean sea level rise in 2050 relative to 2020 from the observation-based projection agree with the AR6 projection and the 3 SSP scenarios, and is closely consistent with the intermediate emission scenario SSP 245 and lower than high emission scenario 585. And also, the likely range of observation-based projection remains far below the low likelihood, high impact storyline. And this suggests that the ice sheeting instabilities, which can drive a substantial additional contribution to global mean sea rise, have not yet have a large impact in the next 3 decades based on these current observation-based projections. This slide shows several example tide gauge locations for the observation-based projection. Taking this tide gauge Sydney as an example, the sea level rise from observation-based projection by 2050 is higher than AR6 projection under SSP 126 or SSP 245, and is more comparable with the SSP 585 scenario. And for each of these locations, we could see the observation-based projection agrees with AR6 projection in 2050 with a comparable likely range, and also well below this low likelihood, high impact storyline. When comparing the observation-based projection with AR6 at all tide gauge locations, we could see these blue bars denote the observation-based projection, and those yellow bars denote the AR6 projection and SSP 245 scenario, and these green bars show their difference, and this cross symbol denotes the tide gauge where the observation-based projection is significantly different from AR6 projection. And the x-axis denotes all the tide gauge locations to 200 and 22 tide gauge. So we could see the majority, about 96% of total tide gauge show a consistent sea level projections in 2050 within the likely range. And although we could see some stations like these stations along the Gulf of Mexico, we could see the median estimate from observation-based projection is higher than the AR6, but the likely range of the observation-based projection remain lower than the low likelihood, high impact storyline. And this also indicates that current local observation do not yet support a systematically exceedance of high-end AR6 projection at global scale in the next 3 decades. Here are some main conclusions. So the observation-based projection are comparable with the AR6 projection at most tide gauge locations, and this help us build confidence in the likely range of the AR6 projections. And also, the aim of this study is not to replace the IPCC projection, but to offer a meaningful empirical insight for the near-term sea level rise by 2050 without running sophisticated climate models. And this is particularly important given the uncertainty in some physical processes in the ice sheet models. So that's all. Thank you for your listening.